Welcome to Rate of Change. My name's Mrs. Chapman, and today we're going to be talking about the slope of a line concerning rate of change. In the notes that you have, we have a slope is the same as rise over run, which is the exact same thing. Your rise is your change of your y coordinates. Your run is your change of x coordinates. And the change of y equals y2 minus 1. You're taking the difference between your y points. And your change of x, or your run, is the change of your x. That's an x. Your x coordinates. So when we take a look at a point, this would be 1, 2, 1, 2, 3. So this point would be 2, 3, and this point would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 would be 7, 6. If we have 2, 3, and the point 7, 6, this is considered my x-coordinates, which is my first x-coordinate and my second x-coordinate, and then my first y-coordinate and my second y-coordinate. And when we take a look at the slope of a line, I can never draw a line straight on here. You take a look at the change. You can't calculate it going straight, so you have to go over, which is your x2 minus x1 will give you how far, and your y2 minus y1. So for example, 7 minus 2 is 5, and 1, 2, 3, 4, 5. 7 minus 2 is 5, and then you take the difference of your y-coordinates, 6 minus 3, which will give you, you're going up 1, 2, 3. So our rate of change is my y over x, and it's the change, that symbol means the change of y over the change of x, which is 3/5. Let's go on to example number 1. Our first point is -2, 2. Our second point is 3, 4. And the reason I'm going to go ahead and put these on top of each other, because it's easier to say these are my x coordinates and these are my y coordinates. And if I kind of set it up as a table and subtract, I'm able to take care of it. I'm going to go ahead and plot these points so you can see them. My first point is -2, 2. 1, 2. To the left, 2, and up 2. My next point or ordered pair is 3, 4. 1, 2, 3. 1, 2, 3, 4. And my answer should be the change of these 2 points. So I'm going to the right, 1, 2, 3, 4, 5, and I'm going up 2. So when I subtract, my answer should be 2/5. Let's see what I get. I always do my y first. 4 minus 2 is 2. Looks like a Z. And then 3 minus a -2, which we all know that becomes a positive, which is 5. And I get the change, or the rate of change, which is 2/5. Let's try another one. Let's go blue. Okay, we have find the slope of the line passing through -1, 2, and 3, 2. So we plot the first point, which is -1, and then up 2. Our second one is 3, 2. So I'm going to go over 1, 2, 3, and up 2. If you notice, they're not at different heights. They're on the same y-axis. In this case, when I'm looking for the rate of change or the change of y over x, if I do it just based on the graph, I'm going to go over 1, 2, 3, 4, but I'm not going to go up anywhere, so that's 0. So I should get 0 over 4. Notice this is a straight horizontal line. Let's go ahead and subtract and see what I get. I'm going to do, these are my x's, these are my y's. I'm going to do my y's first, 2 minus 2, which equals 0. And then my x's, 3 minus a -1, which we all know that equals plus, so that gives me 4. This matches, so I did it right. And anytime you have 0 in the numerator, your slope is 0. The reason your slope is 0 is because it's a straight line. It's horizontal. There's no slope in the road. Slope in the road means there's a hill going up or down, and it doesn't occur here, so your answer is just 0. Okay, I want to go back up to example 2 for a second. When you see a horizontal line like this, when your line is horizontal, your slope will always be 0. Because it's not a hill. It's not any kind of a hill. It's not going up. It's not going down. It's not positive. It's negative. It's just a straight road. Okay, let's go down to example number 3 and see what happens. Let's take a look at example 3. Find the slope of a line passing through. I'm going to set up my chart. And this will be my x-coordinate, this will be my y-coordinate. I'm going to take my first one, which is 3, -3, and my second one, which is 0, 0. Now I'm going to go ahead and plot them. 0, 0 is right here, and then I'm going to move over 1, 2, 3, and the -3, so I'm going to go down 1, 2, 3. Okay, now notice this line is going down. Look at the other ones. For example, example number 2 is just a straight line. Your slope is 0. If you look at example number 1, your slope is positive, and this line is going up. If you start always in this corner, start right here in a graph, you can tell if a slope is going up. If a slope's going up, it's going to go from bottom up. If your slope is going down, it's going to start up in this corner and it's going to go down. A lot of people have trouble with that. When your slope is negative, your rate of change will also be negative, and that's why I'm taking a look here. Now, notice if I extend this line, it starts up here in the corner, and it's going to go in a downward motion. So I know right off the bat my slope is going to be negative. Now we plotted these points. let's take a look at our y. I'm going to draw my line from here to here. Okay, my y coordinate is going to go up 1, 2, 3. So my change of y is 3 over my change of x. And my x, I always start at the point, and I'm going toward the x negatives, which is 1, 2, 3. I'm moving toward the negatives, because if you remember, these are my x negatives. So it's going to be negative 3. And when I reduce 3 divided by negative 3, my slope is going to be negative 1. I can tell I have a negative line because my slope is negative. And when I use it in the formula and actually find the difference between the two, my y-coordinate, negative 3 minus 0, negative 3 minus 0 is actually negative 3. And then my x-coordinate's 3 minus 0, which is 3. Now you're going to say, wait a second, Mrs. Chapman, hold on. In this case, your negative's in the denominator, and in this case, your negative's in the numerator. How can they be the same answer? Well, the thing with negatives is as long as you have only one negative, your answer can be true. Your answer can be correct. It can be negative. So I can have 3 divided by negative 3. I still get negative 1. Try it on your calculator. I can have negative 3 divided by 3, and I still get negative 1. It doesn't matter. That's when your slope is going to be negative. When I have two positive answers, 3 divided by 3 equals 1, or negative 3 divided by negative 3 equals positive 1. So if I have no negatives or if I have two negatives, that's when my answer is going to be positive. Okay? I go basically on, if I have one negative, my answer is negative based on the division rules using negative properties. Example 4. Find the slope of the line passing through 2, 4, and 2, 1. Once again, I have my 2 points, x, y. I'm not very good at drawing. Okay, so my second point is 2, 1. My first point is 2, 4. I'm going to subtract them. Before I do that, I'm going to go ahead and plot them. And I'm going to plot 1, 2, and then up 1, 2, 3, 4. My second one is 1, 2, and I'm going to go up 1. Notice I have a complete cliff. I call it the cliff, kind of like a cliffhanger. You can't drive up it and you can't drive down it. Therefore, my answer is going to be, I'll automatically know when you have a vertical line, it's going to be undefined. The reason it's undefined is you can't drive on the road that goes completely up or completely down. You can't even tell which direction it's going in. Either way, you can't do it unless you're a rock climber. But we're talking about being able to drive here, not being able to rock climb. So if you notice, on my x value, I don't go anywhere to get to this. I don't go anywhere to get to this point up top. Okay, so what I'm going to have to do is my x value is going to be 0, and I'm moving up 1, 2, 3 spaces. So when I have 0 in the denominator, my answer isn't 0, because try in your calculator 3 divided by 0. You get an error. And when you get an error, it is undefined. It is undefined because you can't drive on a road that goes straight up and down. But what about when I use the formula? Let's go ahead and try use the formula. I have my change of y over my change of x. One change meaning you're going to subtract them. 1 minus 4 is a negative 3. 2 minus 2 is 0. I have 0 in the denominator. If I try to divide, I get an error. When I get an error, it is undefined. Why is it undefined? Because I can't drive up the road and I can't drive down the road. It's physically impossible. Yeah, I know some of you can argue that, but that you would like to try it, probably because you're daredevils. But in other words, it's a good way to remember that with vertical lines or the 0 in the denominator, your answer is undefined. As you can see, we have 1, 2, 3. We have 4 different slopes. We have what we call anytime a positive slope. And I kind of touched base on this before. When it starts on the bottom and goes up, it is positive. And this happens anytime your slope is going to be greater than 0. M stands for slope. Anytime your slope is greater than 0, your slope is going to be positive. Your line is going to be positive. Well, then we have what we call a negative slope. And this is anytime your slope is going to be less than 0. It always starts up high and goes down low. That's going to be a negative. And then we talked about the horizontal line. When we have a horizontal line, it's just a complete straight road, no hills, no bumps, hopefully no bumps. And this is every time your slope is going to be 0. And then we just talked about the vertical slope, the slope that goes straight up and down. And this is when your slope is undefined. Now, we saw examples of 4 of these classifications, and now we're going to take a look at finding the slope when you're missing a coordinate. So, in example number 5, notice we don't have a graph. The reason we don't have a graph is because we have a missing slope, missing coordinate right here. We have to find what that missing slope is. But what we do have is we know our slope equals 2/3. This is when we need to use the equation. So our equation is you take the difference of your y coordinates and divided by the difference of your x coordinates, it's going to give you the slope. So now we just go ahead and fill in the blanks. This is your x1, 1, y1, second point x2, y2. And we have everything except for one value, so then we need to solve for that one value. So let's go ahead and plug in our numbers. My y2 coordinate is, I don't know. And my y1 coordinate is 1. Divided by my x2 coordinate, which is 4. Minus my x1 coordinate. I'm going to put in parentheses. And this is a little tidbit. Anytime I put anything in parentheses, anytime I'm substituting numbers, filling them into a formula or for variables, I always put them in parentheses. The reason I do that is because of mistakes that can be made right here. Notice that's a negative 2. I know, it looks like a Z. Equals my slope of 2/3. Well, let's go ahead and make this a little bit prettier. I can't do anything up top, so I have y minus 1 divided by a double negative equals a positive, equals 2/3. Clean this up a little bit more. Y minus 1, 4 plus 2 is 6, equals 2/3. Notice we have an equation in the middle. These are technically two ratios. So you're going to use the same method as solving proportions as you do with solving this, and that's the cross multiplication. You cross multiply, do the butterfly effect. 6 times 2 equals, and here you're going to have to do the distributive property. 3 times, because this is two terms connected through an operation, y minus 1. And now I have myself an equation. 6 times 2 is 12. Distribute 3 times y is 3y, and 3 times negative 1 is a negative 3. Now we can solve for y. I'm going to add 3 to both sides first, and equals 3y, the 0 out, and 3 times 5, or I'm going to divide by 3 here. That's a 3. That equals 1, so I have y equals 5. Okay, so my missing point is 5. This 1 divided by 4 plus 2, which is 4, 6, and that breaks down to 2/3. So my slope is correct when I go back and plug it in. Let's go ahead and take a look at some more examples. If I open my parachute at 2,500 feet, after 35 seconds I was at 2,115 feet. You take the change in height, which is 385 feet, and the change in time, which is 35 seconds. Your time is always your x value. And notice you have it start at 0 seconds minus 35 seconds, so you get a negative 35 seconds. You divide your feet divided by your seconds, which gives you a negative 11 feet per second. So he has fallen at a rate of 11 feet per second, or negative 11 feet, the negative standing for the fact that he is falling. Now that we know the rate of the slope that I'm falling at, or he's falling at, how long will it take for him to hit the ground? Remember, if he's falling at a rate of 11 seconds per feet, you're going to use the time equals distance divided by the rate, or 2,500 feet divided by 11 feet per second. And you're going to get 227 seconds. I will hit the ground. Ugh, that's scary. Okay, let's take a look. The grade of this road is 6%. Got some bugs flying around, doing a little wheelie. It's okay because your slope isn't that big. Your slope and your grade is the same thing, pretty much. So what is the slope if it's the same thing, but the grade is in percent, and we don't know slope as a percent? So you divide the vertical by the horizontal, just like we were doing in the grass.